Good evening, everyone. Welcome back to Telepedia tutorials. So we are still on this topic, electrolysis, and this will be the fourth video in this series. So we have been talking about two different kinds of electrolysis, which are molten electrolysis and aqueous electrolysis. So in this video, we're looking into the key differences. Now, as I told you earlier, to perform electrolysis, you need to convert the compound you want to separate or decompose from solid to liquid. And we said that when we are converting this compound, take for instance sodium chloride from solid to liquid, we can do it by heating it in the absence of water. It reaches its melting point. It now changes from solid sodium chloride to molten sodium chloride. So in such a situation, we are performing molten what? Electrolysis. So in molten electrolysis, there is absence of water. There is absence of water. But when we come to aqueous electrolysis, we are saying that we are dissolving the compound to be electrolyzed inside water. So that is the process we are following to convert it from solid to liquid by dissolving it inside water. So in molten electrolysis, since water is absent, when current is passed into the electrolytes, the ionization of only sodium chloride occurs. So sodium chloride is going to split into sodium ion and chloride ion. But in aqueous electrolysis, since water is present, when current is passed into the electrolytes, both water, which is acting as a solvent, is going to undergo ionization, and the substance we're electrolyzing, here we call it the electrolyte, is going to also undergo what? Ionization. In molten electrolysis, we want to have one cation and one what? Anion. So we already know what is going to be moving to the cathode and what is going to be moving to the what? Anode. But when we come to aqueous electrolysis, since water is undergoing ionization, we are going to have two cations, which are sodium ion and hydrogen ion. And we're going to also have two anions, which are chloride ion and hydroxide ion. Please note, whenever water undergoes decomposition or whenever water undergoes ionization, it is going to form a positive ion, which is hydrogen ion, and a negative ion, which is what? Hydroxide ion. When hydrogen ion combines with hydroxide ion, we form back what? Water. Coming down here, we are saying that when current flows from the positive into the anode, we have two cations, hydrogen ion and sodium ion. We have two anions, hydroxide ion and what? Chloride ion. Now, the positive ones will be attracted to the cathode, while the negative ones will be attracted to the anode. We have said before that anode attracts anions, which are negative. Cathode attracts cations, which are what? Positive. Now, in electrolysis, out of these two cations, only one is meant to be discharged. And out of these two anions, only one is what? Meant to be discharged. Now, you can go through this later on. I think I've explained it so far. So, the big question is this: which of the ions will be discharged at the anode and cathode? So, at the anode, which is positive, which is attracting the negative, is it hydroxide ion that will be discharged or chloride ion? And at the cathode, which is negative, which is attracting the positive, is it the hydrogen ion or the sodium ion that will what? Discharge? That is the big question. Now, to answer this big question, we are going to look into preferential discharge of ions, and the next video I'm going to post. So this preferential discharge of ion are factors that guides us to know which of the competing ions will be discharged in the respective electrodes. So there are three factors that influence this preferential discharge of ions. We have seen number one, position of ions in the electrochemical series. This factor is concerned how strong or how weak are one ion relative to the other, concentration of ions, and nature of what electrode. So we are going to look into these three factors in the next video that I will post. So this will be all for now. Expect the next video soonest.